Hi everybody, welcome to your video for what is going to be all of section 2.2. So we are going to take 2.2.1, 2.2.2, 2.2.3, and 2.2.4, and we're going to combine them all into 2 days. So we're kind of going to throw the book to the side for a little bit, and we are going to condense this down a little bit and make it a little bit easier for us to understand, just because I think this is some stuff that you guys have seen already, and that might be pretty easy for you. Like, for example, this first section, 2.2.1, is all about units of measure. So it literally just talks about different units of measure. That's it. So that one is definitely something we can skip over. I think you guys have a grasp on that. 2.2.2 is how can I find the area of triangles. Then we move on to 2.2.3, which is area of parallelograms and trapezoids. And then 2.2.4 is heights and areas. So it's all stuff we can kind of condense and sum it down into kind of 2 days. So you guys should have your packet that I gave you in class out. You guys are going to take some notes on the first page, and then you guys will have the last couple pages to complete in class on Wednesday and ask questions and making sure we understand that kind of stuff, all of that fun stuff. So you guys will work in groups to go through that packet. All right, so the first thing I have for you guys today is a little joke, you could say. So it says simple geometry. You have a pentagram, or a pentagon, a hexagon, an octagon, and then you have Oregon. And so I just thought that was kind of clever, kind of funny since we were working with shapes. Alrighty, so the very first thing we want to do when we're talking about areas is to write all of these equations down. And actually, these are given to you on your state test resource page. So it's nothing you have to memorize. I haven't decided if I want to make you memorize them for the test or not yet, but we will talk about that as we get closer to that. So the very first line in your packet says the height of any object is always, and you should put in that line perpendicular to the base. So the height of any object is always perpendicular to the base. So when we have something that's perpendicular, remember, it always makes a right angle with the base. So sometimes in these pictures, the height is very easy to see and easy to define. You're like, yep, we got that. But in other pictures, it might not be so easy to see. So we need to make sure that the height is a straight line that is perpendicular to the base, because when we give you all of the lengths and all of the sides and everything's filled in, it might not be as easy to see. Alrighty, so let's go ahead and fill in these these area formulas. So for a triangle, we should hopefully all know that by now, but it is 1/2 base times height. So 1/2 or 0.5 times base times height. Some people also like to say base times height divided by 2. It's all the same thing. So that is the area of the triangle. The area of a parallelogram is just base times height. And if you come over here, the reason that it is just base times height is because it's really just a rectangle. If I were to take this section right here and relocate it over here, it forms a rectangle. So a rectangle formula is length times width, which is the exact same thing as base times height. So parallelogram is just base times height. So all of these should go on those lines where it says area equals on your paper. And then the trapezoid, which is probably the most complicated one, is 1/2 parentheses base 1 plus base 2 times height. So this is the only one we really have to be careful about when plugging it in our calculator, that we're doing it correctly. If you want to plug the whole thing in your calculator, you have to type it as you see it with parentheses. So I'd put 0.5 parentheses base 1 plus base 2, close that parentheses, times the height, so that way your calculator knows to add first before doing any multiplication. So those are our 3 area formulas we're going to be working with for right now. We are obviously going to add some more once we talk about circles and different shapes, but for right now, in chapter 2, this is the only areas we talk about. So essentially, they wanted us to spend 4 days just talking about those 3 area equations. So instead of that, we are going to just take 2 days and practice it. Alrighty, so for our examples, we're going to go through the front page right here so you kind of get a gist of what's going on. I'm going to walk you through those. Please make sure you guys are writing down the different stuff because I'll give you guys different pointers and we'll go over different things. And then you guys will have the other 3 pages to do in class, like I said, on Wednesday. So for this first one, what we are going to do is anytime you have a weird shape, a shape that you don't know what the area is, or we obviously don't have an area formula for an L-shaped figure. You want to break it down into figures that you know. So what I'm going to do is I'm going to break this down into 2 rectangles. You could do it. There's tons of different ways you can do it. My first thought was just to break it off right here. Because I know that this side is 5. Now I just need to find my side right here. So how I'm going to do that is I'm going to take 11 and I'm going to subtract 8 from it. And I'm going to get 3. So I know that this rectangle's area is going to be 5 times 3, and this rectangle's area is going to be 8 times 3. So 5 times 3 is just 15, plus 8 times 3 is 24. So my total is going to be 39. Now it is super important that you do not forget your measurements. For area, this guy is feet. So 1 dash is feet, 2 dashes like down here is inches. So it's going to be feet squared. Area is always squared. All right, anytime I give you the shaded area or a shaded figure, I want to know the area of the shades, the shaded area. So unless stated otherwise, but for right now, we're just going to assume that we're trying to find the area of the shaded region. So what we want to do for this question, and don't ask me why C and A and B are all mixed up, I don't know. What we're going to do here is we are going to find the area of the shaded region, find the area of the not shaded region, and subtract them. So for the shaded area, the whole thing, the whole box, even that guy, is going to be 12 times 24, which is 288. And we want to subtract the non-shaded part, which is 4 times 8, which is 32. So 288 minus 32 is going to get me 256. Again, don't forget your measurements. It's going to be meters squared. Alrighty, this next one is not like anything we've really seen before. Actually, we have seen something like this before, but I don't think we've actually put it into an area formula. So if we want to find the area of a rectangle, you just take length times width. So that's exactly what we're going to do. We are going to take 2x plus 3 times x plus 4. 2 different ways to do this. You could FOIL. Which stands for first, outer, inner, last. So essentially what you would do here is you would take the first 2, so 2x times x, and multiply them together. Then you would take your outer 2, so 2x times 4. Then you would take your inner 2, which is 3 times x, and your last, which is 3 times 4. So that's the way I learned how to do it. I just multiplied those across. Or another way we could do this is you could set up the box method. So this is what you guys have done on one of your exit tickets. So you would set 2x plus 3 up top and x and 4 on your side. And this method works really nice when you have like a more stuff to the equations. Like if I was multiplying an equation with 3 parts in it instead of just 2, that's when this comes in really handy. So all I'm going to do is multiply what lines up with this box. So I have 2x times x gives me 2x squared. I come over to this box, I have 3 times x, which is 3x, 2x times 4, which is 8x, and 4 times 3, which is 12. Then the diagonals here should always overlap. So our final equation here should be 2x squared plus 11x plus 12. it'd be the same thing if I did it this way. I would take 2x times x, I'd get 2x squared. 2x times 4, I'd get 8x. 3 times x, I'd get 3x plus 12. So it's the same exact thing. And then you just simplify this middle part. So that would be your final area because you can't do anything else for that guy. Alrighty. Next one looks a little bit more complicated, but we have these nice dashes here that tell us that those are all equal. So if I have this side and this side and this side are all equal, and we know that they have to add up to 27, I'm just going to take 3 and divide it by 27. 27 divided by 3 is just 9. So I know all of these sides are 9. And so what I did, what made the most sense to me is I broke this off into rectangles like this. And I know this is the same thing. I'm going to have 3 divided by 8, which is going to give me 6. This one's a little bit more complicated, though, because this guy I know is 6. This guy right here I know is going to be 12. And then this guy right here is obviously going to be 18. So it's 6. 6 plus 6 is 12 because you got 2 of them right here. And then you got 3 of them to add up to 18. So now what I'm going to do is I'm going to go ahead and do my multiplication. So I have 6 times 9, which gets me 54, plus 9 times 12, which gets me 108, and then 9 times 18, which gets me 162. Add all those together, and you get 324 centimeters squared. Alrighty, so I want to find, for this guy, I want to find the shaded area. So I basically want to find half the area. That's what it's asking me to find. So for this guy, I'm going to take, if you think about it, area of a triangle is 1/2 base times height, which is exactly what we're going to do. The base is 14, the height is 5. And we want to find half of this rectangle here. So if you just took base times height, you'd be finding the full thing. So since we multiply it by half, we're finding that half. So I'm literally going to type in 0.5 times 5 times 14 in my calculator. So 0.5 times 5 times 14 in my calculator, just like that. And I get 35 yards squared. Alrighty, last problem and then we're done for the day. Alrighty, same thing. Our equation for a triangle is 1/2 base times height. The base of this guy, we just have to do a little bit of mental math here and say 4 plus 10 gives us 14. So I'm going to type in 1/2 base is 14 times height, which is 5. I know my height is 5 first off because it tells me that. It also is perpendicular to the base. Makes that right angle, that 90-degree angle. So I'm going to plug 0.5 times 14 times 5 in my calculator all together, and I am going to get 35 inches squared. And that is it. So if you guys flip through the rest of your packet really quickly, the next couple of questions is just asking you to type in the numbers that you would type in your calculator. So you're not actually finding the area there, you're just writing the numbers you'd put into your calculator. Then we move on and we get into actually finding the area and the perimeter of each shape, which it gets a little bit more complicated. And then the very back page is just more of that, it's a composite figure. So a composite figure would be something like this example, or like this example where it's not an actual shape, it's something that you have to work through and you have to figure out on your own. Alrighty, so that's all I have for you guys today. I hope you guys have a great night and I will see you in class tomorrow.